Hello and welcome to the homework helper video for section 5.1. In this section we're starting to do the whole process that we've learned backwards. We're starting to take the antiderivative and find the indefinite integral of functions. So you'll have a lot of fun with that, and one of the applications of that is to do these vertical motion problems that we've been doing all semester long backwards. So what we have here is balloons rising vertically. So it's going straight up. We're not talking about any side-to-side motion. With a velocity of 16 feet per second. It releases a sandbag at the instant when the balloon is 40 feet above the ground. And the first question is, how many seconds after its release will the bag strike the ground, right? So we're looking for a time. How long is it going to take for that bag to hit the ground? Okay. You could go ahead and use the same, I've got to change my, hold on, I've got to change my writing tool here. Let's change to this one. You could use the same formulas that we developed before, but they're starting here with a of t. I don't like the size of that. Hold on one second. Let's try this one instead. All right. They're giving us that a of t is equal to negative 32 feet per second, and the squared. And the idea here is that now we can go backwards. We can say v of t is the antiderivative, right? The indefinite integral, or the antiderivative of a of t. So this would be, since negative 32 feet is just a constant, negative 32 is just a constant, we can say it's negative 32 t plus some constant c, right? That's me just doing the antiderivative, right? It was a constant, so it's going to be a t to the first here. C, and now we can actually figure out what c is, right? C would actually be the initial velocity of the object. What was it, a bag they dropped? Yeah, sandbag. It's going to be the initial velocity of our sandbag. So the balloon was already rising at 16 feet per second. So the initial velocity of the sandbag, right when it was let go, is that same 16 feet per second as the balloon was rising. So initial velocity, meaning at time 0, right? Right when I let go of the bag, this will be equal to negative 32 times 0, because it's time 0, plus c, and that initial velocity should be equal to 16 feet per second, right? So c is equal to 16, right, because this is just 0, so c should be equal to 16. So I can rewrite that velocity equation as v of t equals negative 32t plus that initial velocity of 16. And we can now go to, let's see, we want to know how many seconds when it hits the ground. Okay, well, what we've got to know is ground is a reference to position, right? So we've got to find the position function. So we're going to do the antiderivative again. S of t, which is the position function, right? That'll be equal to the antiderivative of the velocity function. So it'll be negative 32 t squared divided by 2, right? We're doing the antiderivative. You raise the exponent. It was t to the first. You raise it by 1 and then divide by that new exponent, plus 16t plus another constant. Now I'm going to say plus. I'm not going to put c again because I don't want people to be confused with this one. It's going to be a different c, so maybe I'll put like c2 or anything just to keep them different, right? So what we want to know is this is going to be the initial position, okay? So we're given the initial position in the problem. In the problem, it tells us that the sandbag was released at 40 feet above the ground. So we know its initial position. I could go through this whole thing again, but keep in mind, for initial position, when I plug in 0, this term will be 0, this term will be 0, and the whole thing should be equal to 48. So C2 is going to be 48, or the initial position. So just simplifying all that a little bit, I've got S of t equals, I'm just going to write this as negative 16 t squared plus 16t plus 48, okay? And what we wanted to know is, when will this object hit the ground? Okay, it's going to hit the ground when this function's equal to 0, right? If I solve that for t, I'll know when it hits ground 0. So solving this equation for t, I think the first thing I would do is divide everything by negative 16, right? So if you divide everything in that equation by negative 16, you should get t squared plus t, minus t, because I'm dividing by negative 16. Minus 16 goes in there 3 times, right? Minus 3 equals 0, right? Okay, so solving this equation for t, unfortunately it does not factor. So what we're going to have to do is a little bit of quadratic formula. So t is equal to the opposite of b, b is -1, so 1 plus or minus the square root of b squared, -1 squared is 1, minus 4 times a times c. 4 times 3 is 12, times 1 is still 12, so plus 12 all over 2a. So 2 times 1, 2. Okay. So it's 1 plus or minus the square root of 13 over 2. And putting those two values into the calculator. Okay, here's my calculator. Let me move it over here so you guys can see it. In parentheses, oops, got something in there already. Let's say in parentheses I've got 1 plus the square root of 13. All of that divided by 2. And that gives me approximately, what's it say there, 2.30. Maybe I'll use more decimal places than that. Let's say it's, okay. What I've got is approximately, where's my pen go? Okay, approximately 302 approximately. Okay. And let's do the other one. If instead I just put in the last entry and do minus instead of plus, right? Because the other one will be minus there. Okay, that gives me a negative number. Now, negative time doesn't make any sense, so I'm going to ignore that negative solution, right? So the time is going to be 2.3. That's about when it's going to hit the ground, okay? It says round your answer to 2 decimal places, whatever. That's 2.30 or 2.3. Great, so that's the first question. Keep in mind, what we're doing here is backwards of what we did before. We used to start with the position function to get the derivative or the acceleration functions. Now we're just doing it backwards. We're starting with the acceleration function and taking the antiderivative to get to velocity, and taking the antiderivative of that to get to position. Okay, so that's the idea. We're just doing that backwards. Okay, how many seconds after? Okay, 2.3 seconds. We answered that first question. I just always check to make sure I actually answered the question. And now the second part says, at what velocity will it strike the ground? After doing the first part, this part is relatively simple. At what velocity will it hit the ground? Well, we know when it will hit the ground, and we've got a function for our velocity, right? V of t is -32 t plus 16. I'm just taking that straight from the previous work that we did here with the velocity function, right? And now I know when it hits the ground. It hits the ground at time, well, let's put 2.302. Just because we're rounding to, we want to round to 2 decimal places, so I'm using 3 so that I get to round correctly here. And this is -32 t. Oh, not t. Let's back up a little bit. I want to put the t value in there. It should be equal to that. -32 times 2.302 plus 16. And I get out my trusty, beautiful calculator again and figure that out. -32 times 2.302 plus 16. Great, and that gives me that the velocity is, come on computer, work with me here, okay. Oh, wow, I really messed that up. Let's make that bigger again, there we go. That velocity should be equal to, and this comes out to be what, -57 point, gotta look at it again. Oh, it sits around to 3 decimal places. Oh my goodness, I didn't use enough decimal places. Oh boy, this is a good teaching moment. Let's go back a little bit. So, I want to use more of the decimal places up here because they're rounding to 3 decimal places. So if I want everything to be accurate to 3 decimal places, instead of using just 2.302, I'm going to use a whole lot more of that decimal to get to 3 decimal places, namely 1 more place. So it's 2.302, but then I'll use 2 more. Why not? Just to be safe. It says 77 up there, right? So 77. I didn't notice they wanted me to round this one to 3 decimal places instead of just 2. So let's use a whole bunch. I get -32 times that value of t, 2.30277. And then plus 16. Okay, so figuring that out on my calculator, let's see what we've got. I wonder where all those these came from. I've got -32 times 2.30277 plus 16. Great. And this gives me approximately negative 57.689, right? Because if I would round up 3 decimal places, it'll be 689. Good. So 6, 8, 9. Just be careful. I didn't have to use all of these 7s, right? But to correctly round to 3 decimal places, I have to at least use this one, the 4th decimal place, so I know whether I have to round that 9 up or down. So it'll be that, and this is velocity, so that'll be in feet per second, right? Well, I hope that helped. Sorry about that confusion at the end. I needed to backtrack a little bit because I needed to use more decimal places to get to 3, but that's the general idea of this application problem. I hope that one helps with this one and the last one in the homework. All the other ones are going backwards, so you're learning all your rules, you're taking all your rules, but you're doing all those rules we've learned so far backwards. Well, I hope that helped. Let me know if you have any questions.